I gotta do something. Oh, there we go. Okay. Today is May 24th, 2011. We are going to do the quiz answers. So the very first question on your quiz, it says the longest slide in the world is in Vermont, USA. It drops 213 meters. It drops 213 meters and in a horizontal distance of 1,200 meters. That wording's a little funny, but how long is the slide? I was hoping that there where I said how long is the slide, you would know which side of the triangle. So normally slides are what part of a triangle? Anyone know? Hypotenuse. Not too many people slide directly straight down or horizontally. Some of you missed that. Okay? Let's set this up. So, it said that the slide drops 213 meters. In other words, here you are, Jeffrey. This is him. He's about to go down the slide. Okay? Here's him. He's doing his written part of 1 billion questions also. All right? He says the slide drops 213 meters. And it says it has a horizontal distance. It directly says a horizontal distance. 1,200 meters. They want to know how long the slide is. So in other words, hypotenuse. Lucky for you guys, we don't even need to use sine, cos, or tan to solve this. I can use the Pythagorean theorem, a squared plus b squared equals c squared being the hypotenuse, to solve. So I'm going to plug these in. It doesn't matter what we call a and b, but c must be the hypotenuse. In this case, we've called cx, so we're going to do x squared is equal to 213 squared plus 1,200. Keep going. I should really have the answer. Okay, so 230. Okay, so as I've said this 3 times now, 213 squared is 45,369 plus 1,440,000 is equal to x squared. When I add those two numbers together, I get 1,485,369 is equal to x squared. I now need to find the square root of both sides to solve for x. So x is equal to 1,218.75. Okay? Whether you said it was 218, some of you rounded up to 220. I was actually okay with that. As long as you got this answer or someone very close to it. That was worth 3 marks right off the bat. The distance of this slide was 1,218.75 meters long. That is over 1 kilometer long. That is a very long slide. Okay? Okay. That was 1. 1b asks us, what is the angle of elevation of the slide? If I look in this triangle, there is only one angle of elevation. It is right here. An angle of elevation that needs to have a horizontal side and then a side heading upwards. We already know one is 90 degrees, and this here is not an elevated angle. We're heading downwards. But as a precursor to what I was talking about before, that is not an angle of depression, which many of you thought it was, just as a heads up. So anyways, like I was saying, this is our angle of elevation. We need to find that angle. I have 3 measurements of a triangle. I can use sine, I can use cos, I can use tan. Any one of those 3 to solve for this angle. I'm going to use tan because I'm going to use the original numbers they gave us. So, tangent, I guess I'm going to do it in red. Theta is equal to, what is it? Thank you, someone knows. Opposite over adjacent, okay? Now we're trying to find theta. So next line will say tangent theta is equal to our opposite side of this angle, 213, and our adjacent side is 1,200. So that's 213 over 1,200. that is equal to 0.117. Whoa, I think I said that wrong. I think it's 1775. Yes, that's it. 1775, sorry. Is equal to tangent theta. Now remember, I'm solving for theta, so I got to bring tan to the other side. When I put tan on the other side, it becomes inverse tan, so tan to the power of negative 1, 0.1775. Theta is equal to 10 degrees. I think it's 10 decimal something, but it pretty much rounds to 10 degrees. So our angle of elevation of this slide is 10 degrees. That's not a very steep slide in that case, okay? I've now found everything I need to find on question 1. Question number 2. Question 2 states, from a spot 25 meters from the base of the building. Now, I'm going to go ahead and make a right angle triangle. I know I haven't read you the question yet, but since we've been working with just right angle triangles, I can kind of make that assumption. Let's make sure by reading it. A spot 25 meters from the base of a building. So let's call this the building. Those are all the windows. Okay? This is you with your math book. And you are 25 meters, that's 425, from the base of the building, which is down here. The base of the building is going to form a right angle triangle, assuming it is not the Leaning Tower of Pisa. The angle of elevation to the top of the building is 65 degrees. So we just talked about angle of elevation. This angle here is the angle of elevation from where you are. It is a straight line distance to the bottom of the building and then heading up to the top. So the angle of elevation is 65 degrees. And the question is asking us what is, or how tall to the nearest meter is the building. So they need to find how tall this building is. So in other words, this is our x. Okay? Since that is our x, I'm going to talk about my 65. This is the opposite side, which we're trying to find. And the measurement we have is our adjacent side. So that means I'm doing a ratio that has opposite and adjacent. Lo and behold, that is tan. Tan theta is equal to opposite over adjacent. So let's plug those values in. Tangent, our theta is 65. Our opposite is our x we're trying to solve. And the adjacent side is 25. Okay? First thing I'm going to do is I'm going to solve for tan 65. Okay? So, put it in my calculator. Tan 65 is equal to 2.144. Then I have to isolate x, which means because this is divided by 25, I have to multiply both sides by 25. Or in other words, when I bring 25 over, it becomes multiplied by. So this now says 25 times 2.144 is equal to x. When we equate that, we get 53.6. 5.6 times 25. Let's just find out. 0.6. Told you. 0.61. They said to round to the nearest meter. So this is approximately 54 meters tall. Okay? So the height of this building is 54. Whoa, what happened there? 54 meters tall. Okay, question 3. Steven's apartment balcony is 75 meters high. From the balcony, he spots his car in the parking lot. He estimates that the car is about 70 meters from the base of the apartment building. So let's set up this triangle. Again, we're working with right angle triangle. Steven's apartment, balcony. So here's his balcony. We'll say it's attached to the building. Oh, that's a terrible drawing. Here's Steven. Massive head. Okay. All right. He's 75 meters above the ground. And here is his car. Let's draw his car. Yeah, he's got a race car. Okay. This is awesome cut. Says it's about 70 meters from the base of the building. This is where most of you made your mistakes. I like that guy said. Okay. Question is asking, what is the angle of depression to the nearest degree from Stephen's balcony to the car? The angle of depression is a straight line distance for where someone is standing or where the point is. And then the angle here. This is the angle of depression. Now, you're going to find, because of our angle properties, that this angle here is actually the exact same as this angle here. Some of you solved for that angle down there. I still only gave you 2 because I knew that you didn't know you were solving for this angle, even though you probably got the right number. Okay? We're looking for that angle there. That is the angle of depression. So in other words, I can either A, solve for this angle here, and then subtract from 90 to find out the other angle. That's supposed to be 0. I don't want it to thing. Or I could have just directly solved for this angle and then like pointed up here, or discussed that that was the angle of depression. You would have had to tell me you knew the alternating angle property though if you decided to solve for this angle down here and say that it was the angle of depression. Okay? So what I'm going to do is I'm going to do the most logical, well, what I feel is the most logical, solve for this angle and then subtract from 90. Okay? So once again, this is my angle. I have an opposite, and I have an adjacent. So in other words, I'm going to be dealing with tangent theta is equal to my opposite is 70 over 75. Most of you have that backwards, where it's 75 over 70. Okay, so tangent theta is equal to 70 divided by 75 is 1.0. Oh, why don't we just do it on here? What? Wait, is that what I wrote? Did I have it wrong? Anyways, let's solve it this way. That is right, eh? Opposite, adjacent. Okay. 70 over 75 gives us 0.93 repeated. I have to bring tan to the other side. So tangent inverse of 0.93 repeated. Okay? So I'm going to find second function tan, and I'm going to take the answer from before, so it's very accurate, equals 43. No, we're not done. 43 degrees. That is what almost everybody got. Yeah, what do you think? That is not what I'm looking for. I need the angle of depression, which means I need to take that number, subtract it from the 90 degrees. So 43 subtract 90 is 37? All right, 47. Yes, that is what I got. Oh, I know what I did. Never mind. 47 degrees. If you got 47 and I get it wrong, it's because you were solving for that angle, and I wanted this angle. None of you pointed to that angle. Make sure you know what angle of depression is, because you'll have another question, at least one on your test. There was another one on this quiz. Some of you were able to figure it out. I'm not sure how, without knowing that definition. But